Greetings to all the respected faculties from the Webstack Academy and everyone watching this presentation. My name is Rahul, studying Computer Science and Engineering at the Dayanand Sagar University. Today, I am excited to present our full stack web application project titled Foodgenie. Food has become an essential part of our everyday lives, and with the rapid growth of technology, the way people order food has completely transformed. Today, instead of visiting restaurants or placing orders or phone calls, customers expect everything to be available at their fingertips. They want to browse restaurants, compare menus, place orders securely, and receive their food with minimal effort. Applications like Swiggy, Zomato, and Uber Eats, and as well as DoorDash, have revolutionized the food delivery industry by making the entire ordering process fast, convenient, and user friendly. The transformation inspired us to build Foodgenie, a modern food delivery platform that brings together customer and restaurant through a single, efficient, and easy to use web application. Our goal was not just to create another website displaying food items. Instead, we wanted to understand how a real world food delivery platform functions behind the scenes. We wanted to gain hands on experience in designing both the front end and the back end, implementing secure authentication, managing databases, handling APIs, and creating a complete workflow that resembles an actual production application. We at the Foodgenie didn't want to create another web page which can simply order food and deliver it to the customer. We have implemented AI using Group, which can create summary for a specific restaurant either by saying it to the user as positive, negative, or neutral from the uh, reviews that is being provided from the users. The name Foodgenie reflects the vision behind our project. Just like a genie instantly fulfills wishes, our application aims to make food ordering simple, quick, and effortless. With one or few clicks, users can discover restaurants, explore menus, add their favorite dishes to the cart, complete secure payments, and place order, all through an intuitive interface. Before starting the development process, we studied several existing food delivery applications to understand what makes them successful. We observed that although these platforms provide excellent services, they involve several complex systems working together behind the scenes. For example, user authentication ensures that customer information remains secure. Restaurant management allows restaurant to update their menus. Databases store users' profile, food items, and order details. Backend server processes requests efficiently. Payment modules handle secure transaction. APIs handle seamless communication between the front end and the backend. Rather than simply copying these platforms, we focused on understanding these individual components and implementing them ourselves. This approach helped us strengthen our knowledge of full stack web application. The motivation behind Foodgenie also comes from a common real life problem. Imagine returning home after a long day of classes or work. You are hungry, but you don't want to travel to different restaurants searching for food. At the same time, restaurants need an efficient way to reach more customers without depending solely on physical visits. The traditional ordering methods often involve several inconveniences. Customers may need to call restaurant to check menu availability. Restaurants may have difficulty ordering or organizing orders manually. Order details may be misunderstood during phone conversation. Customers cannot easily track or review previous orders. Finding restaurants that serve a particular cuisine may also take considerable amount of time. All these issues reduce the overall customer experience. Our project addresses these challenges by providing a centralized platform where users can conveniently discover restaurants, browse menus, place orders, and manage their food preferences. At the same time, restaurants receive structured order information digitally, making order management much more efficient. The primary objective of FOOD-GENIE is to provide a complete digital food delivering ecosystem. Instead of focusing on only one feature, our application integrates multiple essential modules into a single platform. This includes user registration, secure login, restaurant browsing, menu management, food search, shopping cart functionality, order placement, payment processing, and user profile management. By integrating all these components together, we created a system that closely resembles the architecture of a commercial food delivery platform. From a technical perspective, this project also helped us bridge the gap between theoretical knowledge and practical implementation. However, developing FOOD-GENIE gave us the opportunity to help this concept in a real application. For example, we designed relational database tables to maintain data consistency. Authentication mechanisms were used to secure user accounts. The front-end communication dynamically with the backend instead of relying on static pages. In this way, FOOD-GENIE became much more than a college project. It became a practical learning experience that combines multiple software engineering concepts into one integrated system. Now that we have discussed the motivation and objective behind FOOD-GENIE, let us move on to the technical implementation of the project. Every successful software application is built on a strong architecture. It is important to decide how different components of the application will communicate with each other. A well-designed architecture improves performance, makes the application easier to maintain, and allows new features to be added without affecting existing functionality. For FOOD-GENIE, we followed a three-tier architecture. The presentation layer, also known as the front end, the application layer, which contains the backend and business logic, the data layer, which consists of my database as well. System architecture. Let me explain the overall system architecture. Whenever a user orders through FOOD-GENIE in the browser, they are interacting only with the front end. The front end is responsible for displaying the information, collecting user input. However, the front end itself does not directly communicate with the database. I'll show you an example of our front end. So this is the project, and this is the part where the customer will place an order. So this is the front end part. A user can search for a menu, for example, sushi. When I searched for sushi, this restaurant showed up called Daily Sushi. I can click on this, add this product to cart. I can go to cart here and then check out. These credentials are first sent to the backend using the API request. The backend then verifies the credentials by checking the database. If the credentials are correct, the backend returns a successful response along with the user's information and authentication token. The frontend then receives this response and redirects the user to the home screen. This separation between the frontend and backend improves security. The database is never directly exposed to the client. The search process occurs whenever the user searches for restaurant, views menus, add item to the cart, or places an order. Every request follows the same flow from the front end to the back end to the database and back to the back end and to the front end. So the front end architecture here that we've used is for developing the user interface, we chose React. React is one of the most popular JavaScript libraries for building modern web application. So the code for this project is So these are all the codes for the front end part of the project. It contains all the folders that project needs, such as the code for increment of products in the cart. If the order is succeeded, then this will run for the order success rate. For developing the user interface, we used React. React is one of the most popular JavaScript libraries for building modern web applications. One of the biggest advantages of using React is its component based architecture. Instead of creating one huge web page, we divide the application into multiple reusable components. For example, the navigation bar is one component, the restaurant card is another component, the card section is another, and the footer is another. This makes the application much easier to maintain because the changes made in one component automatically reflects wherever the component is used. Another benefit of using React is faster rendering. Instead of refreshing the entire web page after every user action, React updates only the component that has changed. This creates a much smoother user experience. Our front end also includes multiple pages such as login, registration, home, restaurant listing, restaurant menu, cart, checkout, and profile. Each page communicates with the front end wherever data needs to be fetched and updated. The backend architecture. So these are all the codes for the backend part. It contains a config folder. The config folder contains Cloudinary, config.env, and database.javascript files. This Cloudinary is the part where the profile photo of the user is saved in cloud architecture, and this is the config.env file. This database local URI is the uh, URL for the MongoDB database. It also consists the Grok API key here as well. It, this stripe key is for payment integration. We developed our backend using a modern Python framework. For example, if the request is for user login, the backend verifies credentials. If the request is for restaurant details, the backend retrieves restaurant information. If the request is for placing the order, the backend validates the cart, restores the order, updates the database, and finally sends a confirmation back to the front end. Therefore, the backend acts as the central decision making library for our application. The database design. Now let us discuss one of the most important component of our project, the database. Every application requires a reliable way to store information permanently. For Foodgenie, we selected MongoDB because it is secure, efficient, and capable of handling relational database very efficiently. Here, each table secures a particular type of information. Instead of storing information, everything in a single table, we divided our database into multiple related tables. For example, the users table stores user details such as username, email, password, and profile information. The restaurant table stores restaurant details including restaurant name, location, rating, and contact information. The menu table stores food name associated with each restaurant. Each menu item contains information such as the food name, price, description, and availability. The cart table temporarily stores the item selected by the user before checkout. The order table stores completed order details, including order status, customer information, total amount, and timestamps. We've also included the authentication system here. Whenever user creates an account in Foodgenie, their credentials are securely stored in the database. During login, the backend verifies these credentials before granting access. This process ensures the only authorized users can access protected sections of the application. Without authentication, anyone could access another user's profile or order history. Therefore, authentication plays a crucial role in maintaining both security and privacy. In our application, protected routes ensures that users must log in before performing actions such as placing orders, accessing their profile, or viewing previous order. In an unauthenticated user attempt to access these pages, they are redirected to the login page. Data validation. Authentication alone is not sufficient. Each piece of information entered by the user must also be validated. Suppose someone leaves required fields empty or enters incorrect information. Our backend validates the incoming request before processing it. If the request is invalid, an appropriate error message is returned to the front end. This validation prevents invalid data from entering the database and maintains data quality. So let me show you the MongoDB architecture that we've used here. So that for database we've used MongoDB Atlas, and this is the MongoDB that we've used, and this is Postman agent. This is used to connect different APIs and communicate between them. So why did we choose this architecture? The reason that we choose this architecture is because each layer has its own responsibility. The front end plays presentation, the backend processes business logic, the database manages persistent storage. Because these components are independent, the application becomes easier to maintain, test, and scale. If we decide to add new feature in the future, such as real-time order tracking, AI-based food recommendation, restaurant analytics, or mobile applications, we can do without redesigning the entire system. Moving on to the payment workflow. Now let us move on to one of the most important part of the application, the payment module. After confirming the order, the customer proceeds to payment. Once the payment is successfully completed, the backend generates an order record and stores it in the database. The payment status is also updated. Finally, the application displays an order confirmation message. This confirms that the completion ordering workflow has been executed successfully. Although this is an academic implementation, the workflow closely resembles how commercial food delivery platforms processes customer orders. Order confirmation. After payment, the customer receives an order confirmation. This application generates an order entry containing order ID, customer details, ordered items, total amount, order status, timestamp. This information is permanently stored in the database. The unique feature of the Foodgenie that differs from other food delivery platform is that whenever we want to order a food from a restaurant, we have implemented a AI based reviews summary part where a user can click on the view summary, and a summary for this particular restaurant is provided based on the reviews of the user. In this case, review for the restaurant are mixed since the service is slow, food was average, crowded and noisy, but people recommend this restaurant for the taste and ambience. Whereas for this restaurant, it says mixed feelings as well. For this restaurant, the quality was top notch, but the service was slow. So the review for this is mixed. And this the restaurant gets a positive review in overall. So this is the AI integration that we've used here. To conclude, Foodgenie is a complete full stack web application that demonstrates the a practical implementation of modern software engineering principles. The project successfully integrates React frontend, backend, and the database and into a unified platform that enables users to browse restaurant, explore menus, manage cart, authenticate securely, complete payment, and place food orders. Beyond the typical implementation, this project has given us valuable experience in designing scalable systems, developing REST APIs, managing databases, implementing authentication, debugging complex issues, and collaborating on a complete software product. Most importantly, Foodgenie allowed us to transform theoretical concepts learned during our engineering curriculum into practical real-world application. This project has strengthened our understanding of full-stack development and prepared us for solving real industry problems in the future. Thank you for your valuable time and attention. I hope this presentation has cleared a clear understanding of our project and its architecture, its implementation, and the technologies beyond it. I would like to thank the Webstack Academy for providing this opportunity on working on such a wonderful project. Thank you. Bye bye.